Welcome to Chillin' 101. We hope this video helps.
You start by confirming prerequisites, Python 3, 10 scientific packages, and a clean labeled dataset. Next, normalize features so scale differences do not dominate Lorentzian metrics. This reduces bias toward large magnitude inputs. Once done, implement the Lorentzian distance kernel and write unit tests to validate behavior on edge cases, because correctness here prevents subtle failures later. Make sure to split data 70/15/15 for train, validation, and test to monitor overfitting and tune hyper. You now design the classifier. Use a kernel SVM with Lorentzian kernel, or add a Lorentzian similarity layer inside a neural network for end-to-end learning. During training, tune the Lorentzian scale parameter since it controls tail behavior and classification margins. This directly affects precision versus recall. Once done, apply standard techniques, batch training, gradient clipping, and validation-based early stopping to stabilize learning. Make sure to log metrics per epoch and visualize decision boundaries to understand model behavior and failure modes. You finish by evaluating on the held-out test set using confusion matrices and AUC to quantify performance, then measure precision and recall for class-specific concerns. Once satisfied, serialize the model plus the preprocessing pipeline and add versioning metadata so deployments are reproducible. For deployment, containerize and expose an inference endpoint with input validation. If things go wrong, first check for data leakage, severe class imbalance, or a misconfigured Lorentzian scale. These are the most common root causes and are quick to fix.
Thanks for watching. Consider subscribing if we helped you.